So there was this time when the universe was dark. Deep, quiet pad, I'm just gonna say it. This is the biggest scientific breakthrough in my lifetime. First, stars relit space, ending the cosmic dark age via reionization. Slow, brightening synth. Okay, you might be asking yourself, wait, wasn't the Big Bang like super bright? How could there be darkness afterwards? Great question. It's actually not that simple. You see, the Big Bang was indeed very bright, but only for a few 100,000 years. After that, the universe had cooled off enough for protons and neutrons to start combining into atomic nuclei, which then captured electrons and became neutral atoms. That's what we call matter! And since these new atoms were electrically neutral, they no longer emitted light. So everything went dark. Deep, quiet pad, and the universe was in this dark state for hundreds of millions of years until the first stars formed, exploded and spread out the light and heat from their fusion. This ended the Dark Age and started what we call the epoch of reionization, brightening synth with glockenspiel. But here's a question for you. Which came first, the stars or the galaxies? Quiz ping. If you want the answer, you'll have to follow 4 more. But don't worry, I'll reveal it later in this very video. Hopeful rise! Okay, so while the first stars were indeed shining brightly, they weren't quite powerful enough to ionize the surrounding gas. That would take a much more energetic event, and the exact cause of reionization has been a huge mystery in astronomy. There are a lot of theories, but the leading idea is that it was caused by the radiation of supernova. 10 to 200 million years after the Big Bang, when the first massive stars exploded. Their combined energy output was great enough to strip many more atoms of their electrons. This cleared up the darkness and allowed light to travel more easily through space. Brightening synth with bells. We know all this because in 2019, the Hubble Space Telescope detected a faint glow coming from the epoch of reionization. By studying this glow, scientists were able to learn a lot about what was happening at that time. And now, 4 years later, the James Webb Space Telescope has made an even more precise measurement of this glow. It's a technique called spectral analysis, where you take a picture of something and then split up the light based on its wavelength. What they found was surprising. The light from this era was 10 times dimmer than they expected, glimmering synth with harp. This means that the universe was much more opaque back then than astronomers thought, which implies that the intergalactic medium, or the stuff between galaxies, was much more dense. And it also suggests that reionization happened earlier than expected. We're talking about a period just 160 million years after the Big Bang. Hopeful rising synth. And just like that, the universe turned the lights on. No! For your trouble! Here's that answer to that quiz I asked earlier. It was the galaxies. The first galaxies formed out of giant clouds of gas and dust, some of which then collapsed and formed the first stars.